Welcome to another installment from the Wonderware Diving In series videos. In this video, we're going to explore how we can create functions out of ArchestrA graphics that can be used in other graphics. The benefits of doing this are that these graphics as functions provide a single place for us to make changes, provide consistency across graphics, and allow us to identify everywhere that logic is used. This concept can be applied in many different scenarios from simple to complex. Some examples of where this has been applied include simply adding debug logic or log messages to graphics, creating a timer for animation sequences, storing parameters to and retrieving them from the app domain, mapping bits to bytes and integers, parsing comma-separated variables to individual values and vice versa, creating a single place to associate product names to equipment colors, etc. If you don't have an immediate need for this concept, then just keep it in your hip pocket in case you find a need in the future. Let's get into the details. For this example, we are going to apply this concept of using an embedded graphics as a function to create an initialization delay to use across multiple graphics. Let's say that users of the Reactor demo didn't like seeing the flash of uninitialized values on the main display. Instead of seeing the error or uninitialized values for the clock, temperature, level, etc., they want the displays to stay completely blank until it's time to present the actual values. There are a bunch of ways of doing this, but we are going to create an initialization delay function and apply it to these displays in the Reactor demo. So how might we begin creating an initialization delay using a graphic as a function across multiple graphics? Well, like any ArchestrA graphic, we create it by creating and naming a new symbol, adding custom properties, scripting, and any desired appearance. Let's start by opening the IDE and going to the graphical toolbox. We'll create a tool set in the graphic toolbox. And then create our new symbol. We'll name it something appropriate, in this case, initialization delay. In this simple example, we need just one custom property called complete, which will be a Boolean. It will tell the host graphic when our delay is complete. Now that we have our custom properties, we can create the logic for our initialization delay function through a script. Here we'll create a startup script that sets our complete bit to false. And then we'll create a while false script with a period of 5 seconds. After which we'll set our custom property called complete to true. The graphical subsystem requires each graphic to have at least a 1x1 dimension. This makes sense because when we place any graphic in another graphic, the graphical subsystem has to use these appearance aspects to place and scale the embedded graphic. However, functions usually don't require any visible aspects because they're just performing logic for another graphic that will do the display work. To accommodate these needs, we'll create an invisible 1x1 pixel by inserting a line, making it 1x1 pixel, making it transparent, and setting its runtime visibility to false. If we didn't create any visible aspects to our graphic, this would create a problem when we try to insert it in another graphic. Now let's embed our graphic as a function, this initialization delay, into the other graphics where it's needed. We will do this with the clock digital black graphic, the digital 4-digit, and the digital 6-digit graphics. So we open the clock graphic, drop in our initialization delay function, and create an animation link to the visibility of the corresponding graphical components based on the complete bit. We then do the same thing for the digital 4-digit and digital 6-digit graphics. We will fast forward through that portion. Also note that it's good practice, since these last two graphics are part of the original ArchestrA graphics library and we are changing them, that we rename them so that we know they have been modified and they don't get accidentally overwritten in the future. Now that we've made our modifications, let's deploy and view the results. Now we can see that 5-second delay has solved the problem, and the displays no longer show the error value or erroneous values. Instead, they stay blank for 5 seconds and then display the actual values. The benefits of this graphics as a function approach are that we now have a single place to make changes. We have consistency across graphics, and we can identify everywhere that logic is used. For example, if we wanted to make sure we knew which graphics are affected by the initialization delay, we can perform a fake delete where we look at the referenced by section and see everywhere that it's used. If we thought the initialization delay was too long and we wanted to shorten it to 1 second, we could modify the delay to 1 second and change it globally for all of the affected graphics. So let's do that. And now we can view the results of that 1 second delay in the reactor. Some other uses for initialization delays can be to prevent showing values in a display until they've had time to be fetched from either a database or a file or somewhere else, or also to postpone the use of .NET client controls until after they've had a chance to fully instantiate, or postponing the execution of more processor-intensive tasks until other startup tasks have had a chance to complete. However, although we use this very simple example here of an initialization delay, the real reason we're discussing this topic is that you can apply the same concept of using graphics as functions in many other scenarios. For example, in one customer's application, a graphic as a function was used to globally associate HMI equipment colors with an ever-changing roster of products and product names that might be contained in that equipment, whether they were storage tanks, mixed tanks, packaging machines, conveyors, storage shelves, etc. This scenario allowed associating colors with many different products, changing existing color associations, and accommodating new product associations from a single, central place, yet have these additions and changes propagated throughout the plant through simple redeployment. In another application, it is used to convert back and forth between a bunch of individual values and a comma-separated string. That can be handy for passing an array-like group of variables from InTouch into other graphics or from one graphic to another. In other applications, this graphic as a function has been used to map and unmap bits back and forth to integers or bit packs. Another application of graphics as a functions was to share values across multiple ArchestrA graphics without using InTouch tags. This was done by creating a graphics as a function for both setting or writing those values to the app domain and getting or reading those back from the app domain. This approach meant that there was no need to create and manage tags in InTouch in order to pass values around, and it made it a lot easier to add new functionality, make changes, etc., just by changing the set and get graphic functions. It has been used in other timer applications for creating more sophisticated animation sequences, and can be used for something as simple as adding on-show logging during debugging. When evaluating whether this technique might be useful to you or not, ask, is this function that I'm trying to perform associated with display versus non-HMI functionality such as application server, object logic, or PLC logic? And then ask, is the functionality needed in more than one graphic so management in a single location is attractive? If so, then you may have a candidate for this approach of using graphics as functions, with the benefits being to provide consistency across multiple graphics, provide a single place to make changes, and allow you to identify where that logic is used. If you need further assistance or would like to talk to someone further about this topic, please go to the link shown to locate the Wonderware resource nearest you. Contact information can be found in the Contact Us section. Thanks again for taking the time to watch this Diving In series video.